Hello, and welcome to our lesson 8.1, Understanding Percents. So I want to go through some things on percent and make sure we understand what we are doing. So a percent is a ratio, so we can think of it as like equivalent ratios or equivalent fractions that compares a number to 100. That is because the word per literally means out of, and cent means 100. So out of 100. So 17% is the same as 17 over 100, or 17 to 100, or 17 cola 100. We can write it like we've been writing ratios. For our purposes, we are most likely going to use the one that looks like a fraction. And one of the things that we'll need to do is when we need to compare fractions is we can compare them and think of them as percents. That means, as I said, out of 100. So as we've done equivalent fractions and equivalent ratios, we want to figure out how each of these compares to 100. And again, we use patterns of multiplication or division. So that means 25 times some number is going to be 100. Conversely, 100 divided by some number is 25. So if you know 25 times some number equals 100, if you know what goes in there, then you can work the problem. If you don't know what goes in there, you can think of it as reverse, as 100 divided by 25 equals some number. We're using that idea of multiplication and division fact families. So if you say, well, I don't know what that is, then you are going to have to do long division. And in this case, you cannot divide 25 into 1. You cannot divide it into 10. You can divide it into 100. That is the problem. And so you're going to have to use guess and check. So I'm just going to come over here. And some of you might know that 25 times 1 is 25. And you might know that 25 times 2 is 50. You might have to do long division or long multiplication to know that 25 times 3 is 75. And you might have to do long multiplication to know that 25 times 4 is 100. So it's going to be 4. Let's scroll this down. So if I'm multiplying 25 by 4 to get 100, I need to do the same thing on the top. And that means I need to erase some of this work here. I actually need to multiply 17 by 4. Whatever you do on the top, you need to do on the bottom. So let's set this up. 17 times 4. And we're actually going to do this. So 7 times 4 is 28. Carry the 2. 4 times 1 is 4. Plus another 2 is 68. They also want us to shade that in. So this is a 10 by 10 square. That means each of these rows has 10 in it. So that's 10, 20, 30, 40, 50, 60, 61, 62, 63, 64, 65, 66, 67, 68. Okay? Now, we're going to do another problem, and we're going to compare 33 over 50 to some number over 100. And hopefully we realize that 50 times 2 is 100. So I'm going to take 33. I'm going to multiply it by 2. And I'm going to get 66. So this is going to be 66. And I'm going to shade that in. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So we've shaded in 66 over 100. I'm going to erase some of this work that I've done over here. And now I need to figure out how 20 times what is 100. So maybe I have to do some guess and check. And if I have to do some guess and check, I would look at the first digit over here is 2, divide into 10. And I know that 2 goes into 10 5 times. So I'm going to guess if I did 20 times 5, and I want to switch my color pen here because I'm doing a different problem. 0 times 5 is 0. 5 times 2 is 10. So I is multiplying by 5. So if I multiply by 5 on the bottom, I need to multiply by 5 on the top. So 14 times 5. And 5 times 4 is 20. Carry the 2. 5 times 1 is 5, plus another 2 is 7. So I can finish shading this in. This should be 7 lines. 1, 2, 3, 4, 5, 6, 7. But I can see that player 3, or in blue, has the highest number of free throw percents. And how did you determine? So basically, I just wanted you to know, you can write this down if you want to, if you convert each fraction, or you can use the word ratio, to an equivalent fraction with 100 as a denominator, you will get the percent. Okay? So 17 out of 25 is equivalent to 68 over 100. That's 68%. 33 over 50 is equivalent to 66 over 100. That's 66%. 14 over 20 is equivalent to 70 over 100. That's 70%. On the next page, they show it with some bar diagrams, but really I would want you to continue to do this idea of equivalent fractions or equivalent ratios. So if we had 1/4 equals some number over 100. We did on the last page, go back. You always want to have your work kind of organized so you can look at it. We did this over here, this 25 times 1, 25 times 2, etc. And we found that 4 times 25, or times 25, is 100. And 1 times 25 is 25%. 25 over 100 is 25%. On the next problem below, 1/3. Again, we're going to compare this to 1 over 3 is equal to some number over 100. 3 times some number is 100. I don't know what that is, but I can work it backwards and do division and do 100 divided by 3. 3 doesn't divide into 1, but 3 does divide into 10 3 times. 3 times 3 is 9. Subtract, bring down the, so that's a 1, subtract, bring down the 0. 3 goes into 10 3 times. 3 times 3 is 9. I would put a decimal here and a 0, but I can start to see that I'm going to keep getting this repeating 3. You can use a bar notation over that, or you can say 1/3 of 100 is about 33%. Again, we are using equivalent ratios where the second ratio, the second fraction, is equal to 100. The denominator, the denominator, the second fraction, the second ratio is 100. The other thing you can do, if it helps, is you can memorize some of these benchmarks. So for instance, 1/10 is 10%, 1/4 is 25%, 1/3 is 33 1/3%. We wrote it as 33.3 with a bar. And it is useful if you memorize these to have some things to help you. 1 is 100%. But what I want you to be able to do, and we'll just check a few of these here on the your turn, is convert these into ratios or equivalent fractions, whichever word you want to use, where 100 is the denominator. So in this one, to get from 10 to 100, I can multiply by 10. I do the same thing on the top here. 9 times 10 is 90. For the next one, 2/5, I can think about it over 100. 5 times some number is 100. If I'm not sure what that is, I can work it backwards and I can say 100 divided by 5. 5 does not go into 1. It does go into 10 2 times. 2 times 5 is 10. Subtract. I have a 0. I bring down another 0. 5 goes into 0. This is the tricky part. It goes actually in 0 times because 0 times 5 is 0. And my answer is 20. Okay, so if I'm converting it, this is 20%. And this one is 10%. Let's look at this question now here. 64% of the animals at the animal shelter are dogs. About what fraction of the animal shelter are dogs? So, a few things I want you to be able to do here. You should be able to say 64 over 100. If we wanted to simplify that, so let's talk about this. If I needed to simplify or reduce, we need to find a number that divides evenly, and evenly means no remainder. Okay, so you want to find a factor or number that divides evenly or no remainder into both numerator, that's the number on the top, and denominator. So in math, we have a weird vocabulary sometimes. We want to make sure we understand that. So we're going to simplify or reduce, meaning we're going to find a number that divides evenly, has no remainder, into both the numerator and the denominator. And I'm going to tell you, if you're not sure what to do, if both numbers are even, use the number 2. Okay? So let's start with that. So we're going to divide the top by 2 and the bottom by 2. And hopefully you remember from earlier, 100 divided by 2 is 50. So I don't have to do much work there. But I may not know what 64 divided by 2 is. So I'm going to come over here and I'm going to do 64 divided by 2. 2 goes into 6 3 times. 3 times 2 is 6. When I subtract, I have nothing left. Bring down the 4. repeat, guess and check. So 2 goes into 4. Now I know that that's 2 times. 2 times 2 is 4. Okay. So now I have 32 over 50. But if both numbers are even, let's simplify by 2. So I'm going to keep going here. I'm going to divide the top and the bottom by 2. And hopefully you remember, or you could do the long division, that 50 divided by 2 is 25. Okay? But now I have to do 32 divided by 2. So 2 goes into 3 one time, and 1 times 2 is 2. And we're going to subtract. 3 minus 2 is 1. I'm going to bring down this 2. And 2 divides into 12 6 times, because 6 times 2 is 12. Okay? So now, can we go simpler? If both numbers are even, use 2. In this case, both numbers are not even. Okay? If both numbers are divisible by 5, and those would end in 0 or 5, I would divide by 5. 25 is divisible by 5. 16, not divisible by 5, so that doesn't work. And then I would say check 3. And you can check 3, or you can know that if these numbers add up to a multiple of 3, then it's divisible by 3. For example, 16, 1 plus 6 is 7. 7 is not divisible by 3, so this is not divisible by 3. 2 plus 5 is 7. 7 is also not divisible by 3, so this is your final answer. So if you check 2, 5, and 3 to simplify, and then you keep doing it if you need to, you will get the simplest form. For the next part of the classwork, you are going to look at the guided practice. Okay, and really what I would like you to do is actually do something a little bit different. So let's change some of these. I want you to convert, for this one, 1/5 to a percent. I don't want you to do the benchmark. I want you to convert 6/10 to some number over 100. I want you to convert 2/4 to some number over 100. And I want you to convert 4/5 to some number over 100. And then I want you to do problem 6. So I'm going to give you a moment. I want you to pause the video, stop it, try these problems, and then check your answers.